What is the weirdest thing humans have ever found on the moon? It's not aliens. It's not a secret base. It's something that shouldn't be there at all. With the unveiling of our new manned lunar landers, this discovery has become crucial. Since the Apollo astronauts last walked on the moon over 50 years ago, half a century has passed. No human footprint has touched that soil since. However, we have thrown dozens of probes at it. Some landed successfully, some just flew by, and others were intentionally crashed into it, just to see what kind of splash they'd make. Generally speaking, the moon is the celestial body humans have studied the most. But even after decades of research, the moon remains full of mysteries. Whether it's how it stores heat, how it conducts electricity, or even the properties of its soil, we still know far too little. The universe seems to be like this. The more you study, the more problems you find. For example, we had high hopes for lunar soil, but after bringing it back, discovery after discovery revealed chemical traces that shouldn't exist, leaving scientists scratching their heads for decades. You might think, a scientific discovery changes everything immediately. But true scientific progress is very slow. Sometimes, even when everyone sees the evidence, no one believes it. This story starts back in 1976. At the time, the Soviet Union launched an unmanned probe called Luna 24 to the moon. It was their final mission, to dig up lunar soil. Nobody paid much attention to it. It wasn't the first time, and the scale wasn't huge. But actually, it quietly did something big. It drilled about 2 meters beneath the surface, extracted a core sample, and sent it back to Earth. The sample was only 170 grams, about the size of a baseball. It wasn't much. But inside that narrow tube of dust, something strange appeared. A trace of water. About 0.1% of the sample contained water. And the deeper they looked, the more water they found. This should have been huge. But instead, scientists assumed the water was from Earth, that the sample was contaminated. Maybe from the lander. Maybe from equipment back on Earth. Because the textbooks clearly stated, the moon is dry. It cannot have water. And this wasn't the first time. Earlier, soil brought back by American Apollo astronauts also showed similar hydrogen signals. But that was also ignored as contamination. And so, these clues that should have caused an uproar just gathered dust in lab reports. For decades, forgotten by everyone. It wasn't until the turn of the century that people started to realize, did we miss something important? But just as we got ready to go back and check, the moon was ready to throw even more problems at us. If you were dropped on the edge of certain craters at the lunar poles, you would see an unnatural sight. Not because of what is there, but because of what isn't. There is no light. Only eternal shadows that haven't moved for billions of years. These areas are called permanently shadowed regions. Why does this happen? Because the moon stands up remarkably straight. Its tilt is only about 1.5 degrees. This means, when sunlight hits the poles, the light just skims across the surface. The craters are large and deep, so sunlight can't get in. So, for almost the entire history of the solar system, those places have never seen a single ray of sun. It's not just cold. There is no thermal cycle. The coldest spots there can reach minus 240 degrees Celsius. That's colder than Pluto. It is arguably the coldest place in the solar system. In the 90s, scientists started wondering if comets or asteroids carrying water ever hit the moon. Would water vapor drift into these craters, freeze instantly, and simply never leave? This idea caught fire because it meant the moon might not be a dead rock. It could be a resource depot, a future gas station. Since then, everyone's eyes have been focused on the lunar poles. Looking from Earth wasn't enough anymore. We had to go there and check. But the problem is, the most promising places are also the hardest to reach. Complex terrain and zero light. Solar panels are useless there. But the temptation was too great. What if there really is ice? So, wave after wave of missions began. With one goal, find solid evidence. And that's when things started getting weird again. Scientists suspected ice was there. What's the next step? Send a scout to look. But landing directly was too risky. So the first few missions just orbited overhead. The first was NASA's Clementine mission in 1994. It wasn't looking for water. It mainly mapped most of the moon and confirmed that the South Pole does have these massive permanent shadow craters. But it didn't carry the right instruments, so it couldn't confirm if there was actually ice in the dark. By 1998, NASA launched the Lunar Prospector. This time, they were hunting for water. It used a special instrument to scan the moon. The result? At both poles, especially in those shadow zones, it found massive hydrogen signals. Scientists were thrilled. Theory estimated ice reserves there could be tens of millions, maybe even hundreds of millions of tons. This isn't just a puddle. This is a discovery that changes global politics. But here's the catch. Finding hydrogen doesn't mean finding water. It could also be part of a hydroxyl group, or locked inside minerals. The instrument couldn't tell the difference. It could only say there was hydrogen-bearing material, but not if that hydrogen was part of water ice. So what was it? Actually, even if it was water, the orbiter couldn't see it clearly. So it wasn't solid proof. This made the scientific community scratch their heads again. We had data, we had clues, but we couldn't confirm it. It's like the moon is telling you it has a treasure, but refuses to let you open the box. So scientists thought, since we can't see clearly from above, let's be direct. Let's crash into it. You heard that right. Smash the moon. The logic is simple. If ice is hiding at the bottom of a crater, and I can't see it from above, I'll throw something heavy at it to blast it out. If the debris flies into the sunlight, I'll be able to see what it is. It's a crude method, but effective. The first attempt came from Lunar Prospector after completing its mapping mission. In 1999, it was deliberately crashed into a crater near the lunar South Pole. Unfortunately, this attempt failed. No water was detected. The results were inconclusive. Some said the impact angle was wrong. Others said the impact was too light. 10 years after that failure, in 2009, NASA's Lacrosse mission brought a turning point. This time, they got serious. It brought a Vanguard, the spent rocket stage that carried it to space. They used this giant hunk of metal like a cannonball, smashing it near the South Pole, into a crater named Cabeus. Minutes later, the Lacrosse satellite itself followed the same path, flying directly through the debris plume to analyze it on the spot. This time it worked. The onboard instruments detected water vapor in the plume. Not a hint, but real measurable water. Not just water, but also methane, ammonia, and other compounds. This was the first time humans truly touched water on the moon. Headlines around the world reported the event. Scientists popped champagne, feeling this decades-old mystery was finally solved. But soon, new questions arose. We blasted it out. But exactly how much water is there? Is it blocks of ice? Or ice crystals mixed in the soil? Crucially, is it easy to dig up? Lacrosse gave us an answer, but it was destroyed in the impact, so it couldn't provide more info. We only knew water existed at that specific point. The full picture of the moon remained a mystery. For a long time, everyone's thinking was straightforward. If the moon has water, it must be hiding in those coldest, darkest permanent shadows. Sunlight never touches those places, like a natural deep freezer. Ice could stay there for billions of years. The logic is sound. But the moon always has a new trick. Orbital probes, like NASA's Lunar Reconnaissance Orbiter LRO since 2009, and India's Chandrayaan-1, started picking up something else. Outside of those deep freezers, on the sunlit lunar surface, they caught faint signals of water molecules. This completely baffled everyone. Finding water where the sun shines. Daytime temperatures there hit over 100 degrees Celsius. Shouldn't the water have evaporated long ago? What's even more confusing came next. Scientists found these water signals weren't constant. They followed a schedule. At noon, when the sun is strongest and the surface is hottest, the water signal weakens or disappears entirely. But by evening, as the ground cools, the signal returns. What is this? Is the moon sweating? Sweating in the heat of the day and absorbing it back at night? This phenomenon defied logic. Remember, the moon is a vacuum environment. No atmosphere, no pressure, and no weather. On Earth, water evaporates and condenses to form clouds and rain. That's the water cycle. But the moon is barren. Where is its water cycle coming from? This was absolutely a top-tier puzzle thrown at us by the moon. So where does this water come from? Scientists came up with a few possibilities. One theory is special delivery from space. Every day, countless dust-sized micrometeoroids hit the moon. They might carry a bit of water themselves, or smash into the lunar minerals, releasing water locked inside. Another theory is even more interesting. It's blown there by the sun. The sun constantly blows out a stream of charged hydrogen particles, known as solar wind. This wind hits the moon, and the hydrogen slams into oxygen in the soil, synthesizing water molecules right on the spot. Whatever the source, this discovery completely changed the game. It means we might not be forced into those dark, cold, impossible to develop polar craters. Perhaps the entire lunar surface is thinly moistened with water. It just depends on if we have the skill to collect it. Suddenly, the range of locations for a future moon base expanded infinitely. This tempting possibility directly spurred the next generation of missions. So in 2023, scientists from India challenged this ultimate puzzle with the Chandrayaan-3 lander. Its target was the South Pole, the area scientists believe has the highest concentration of lunar ice. This was the first time humans sent a lander to the South Pole. Everyone watched with wide eyes, waiting for the Pragyan rover to send back news of ice. The rover started moving, using lasers and X-rays to analyze the soil thoroughly. The result? Aluminum, iron, calcium, sulfur. It found everything except hydrogen. No hydrogen means no water. This stunned everyone. Where is the water? The maps clearly marked it. Did we get it wrong before? Or is the water hiding too deep for the rover's small scoop to reach? Before anyone could figure it out, the 14-day lunar night arrived. Temperatures plunged to below -100 degrees. Chandrayaan-3 didn't survive, falling into eternal sleep. It left us with a mystery, even bigger than before. But Chandrayaan-3 didn't go in vain. Before it died, it accidentally found a key clue using a temperature probe. It measured the lunar soil temperature. The surface, baked by the sun, was over 60 degrees Celsius, but just 8 centimeters down. The temperature plummeted to -10 degrees. That difference is massive. What does this mean? It means the top layer of lunar soil acts like a thick thermal blanket. The heat from outside can't penetrate it. This perfectly explains why the rover found nothing on the surface. Because the water ice is likely just a few centimeters below that thermal jacket, hiding safely. So, it's not that there is no water. It's that our shovels were too short. So the question isn't whether the moon is dry, but that our tools aren't sharp enough to dig properly. If this is true, then the next lander doesn't need to fly farther or look better. It just needs a stronger drill. For decades, finding lunar water was seen as a scientific curiosity, a way to understand moon history, geology, and how water moves through the solar system. But that's no longer the main reason we are interested in it. Today, lunar water means something much more direct. A springboard for humanity into deep space, and the cornerstone of a future space base. Because if we can find usable water on the moon that we can extract, purify, and store, it unlocks everything else. First, it makes long-term moon missions possible. Water is heavy. Launching it from Earth is incredibly expensive. Water in space is worth its weight in gold. But if astronauts can get water locally, it reduces the supplies they need to carry. This water can be used for drinking, cooking, cleaning, or cooling equipment, without relying on constant shipments from Earth. Second, water can be split into hydrogen and oxygen. This is the same fuel combination used by many modern rockets. If we can build a system to extract water ice and convert it into propellant, then the moon isn't just a destination, it becomes a gas station. A place where spacecraft heading for deep space, Mars, asteroids, or beyond, can refuel before moving on. This changes the entire calculation of space travel. Currently, every mission must carry all its fuel from the start. But a supply depot on the moon lightens the load. Launching from the moon is also easier. Its gravity is only 1/6 of Earth's. This means less energy, lower cost, and greater flexibility. A spacecraft launching from the moon doesn't need a massive rocket. It just needs a nudge. Third, local water changes how we build. It can support closed-loop life support systems, recycling waste into usable resources. It could even help grow food. Some plants can grow in lunar soil under controlled conditions, but they still need water. If we find enough water, future habitats won't have to rely entirely on resupply drops. This will be pivotal for future human space exploration. although we are still unsure exactly how much water is available or how easy it is to get. All these fuel depots and missions beyond the moon can only happen if we can first actually extract that water. And that brings us to the final problem. Despite so many missions, data, and optimism, the truth is we still don't have a clear path. Every time we feel like we've figured the moon out, it shows us something new. A contradictory reading, a missing signal, an unexpected result. This pattern repeats over and over. We saw strong hydrogen signals from orbit, but upon landing, the soil had no hydrogen. We found signs of water vapor in the impact plume, but no frost, no ice sheets, no visible accumulation. Even in craters that haven't seen sun for billions of years, places cold enough to freeze ice forever, high-res cameras still haven't captured anything clearly looking like ice. Instead, we get ambiguity. Shallow probes found nothing. Instruments detected water disappearing during the day. Rovers drove over craters that were supposed to be full of frozen material, only to find more dust. Even new tech like the shadow cam, which can image the darkest places on the moon, has not yet revealed the clear reflective ice blocks scientists hoped for. This raises an uncomfortable question. What if we've been wrong about how the moon stores water? What if the models need fixing? Or worse, what if water does exist, but it's distributed so thinly, buried so deep, or chemically bound to soil so tightly that we aren't ready to harvest it? Optimistically, perhaps our tools, though precise, aren't good enough yet. Our orbiters are like eyes in the sky. They see wide but can't touch. Landers and rovers are like fingertips. They can touch but can't dig deep. All our probes are just scratching the surface. It always feels like we are just one spectral scan away. The data sent back is full of riddles. It tells us there is hydrogen, but not if it's in water or rock. It tells us this area is bright, but not if the shine is from frost or just reflective minerals. But the word "give up" doesn't seem to be in the human dictionary. Quite the opposite. The denser the fog, the more our curiosity is ignited. New missions are queuing up. Stronger landers are being built. Everyone's eyes are still fixed on that spot, the place we believe holds the treasure. The next mission will bring a more advanced prospecting tool. It will carry a deeper drill, a smarter extraction system. No more guessing. We are going to pierce through that last layer, once and for all, digging up a cold, solid future from beneath the insulating lunar soil. The moon might joke with us again, revealing even more unsolved mysteries. But when our drill finally brings up that handful of cold, solid future, a new era, grander than the moon landing itself, will begin. By then, this blue planet beneath our feet will no longer be just a cradle of civilization, but the harbor from which we sail into the stars.